Hello, everyone. Welcome to Earth Engine Operationalization. This is one of the longest words I've ever included in a slide title. I'm probably going to stumble over it today. Ooh, not starting off on the right foot. These are the slides, tinyurl.com/ee-slides. My coworkers were upset that I got that link. Yeah, you can follow along with the slides. We will also have this, but with code, EE code, a bit later, but if you want to preload that, get ready. My name is Michael. I am a developer relations engineer on the broader geosustainability team. I have been an engineer on the Earth Engine, sort of in the Earth Engine mix for almost a decade. I started in 2012 working on Earth Engine as a software engineer, building out a lot of different pieces of the Earth Engine architecture. So components in the back end, image processing algorithms, data manipulation, moving data around algorithms, extracting information, all the way through front-end components, some pieces of the Earth Engine code editor, Earth Engine apps. I've worked a bit with data, so I've touched many of the pieces, and I am really excited to show you all things like this, of stitching together Earth Engine in an operational way. And so step one is really defining what operationalization means, because it's a buzzword. As an engineer, I'm like pretty allergic to buzzwords. I saw one I was looking for a definition, and this is mine, so don't take this as canon. I like this. This is how I think about operationalization. One particularly poignant blog post said, operationalization is a big word that really just means do. It is all hat and no cattle. So here we go. This is my definition. I really think, so you can read it. I think the fundamental idea here is making a process automatable. So you can, there are two like golden words when we talk about doing large data processing at scale, and really kind of anything at scale. Operationalization boils into sort of standardization and automation. And so this is going to talk mostly about automation. So you don't need to define process. I just wanted to use all four of the Google colors. Make it easily and robustly repeatable. So easily, pretty obvious. Robustly, I really want to focus on not having code that's error prone and not having things that I have to garden. So stuff I shouldn't have to go back and keep updating. If I have a process, we have this idea in engineering about toil, where I just have something that I'm doing all the time and it's not really rewarding or intellectual work, it's just churning. I have to go press a button, I have to go turn a wheel. We want to avoid that, and we want to do that in an easy and robust way, and really the expectation with operational work is that it happens often, if not many runs concurrently, then many runs over a duration of time. Okay, so this is what we're working with. I see everybody's still here. We're getting more people. Welcome. The slides are here. You can ask a neighbor. tinyurl.com, EE slides. We'll need these. This is going to be a hands-on session. We have a contingent of Googlers. I see them. If you get stuck, please raise a hand, talk to a neighbor, shout out, ask me. We're gonna work real quick in this 55 minutes that we have left. But the goal is for you all to leave with code that is running in cloud and is automated and is operationalized. Okay. This is it. This is all we're doing today. This is everything. The first one is really running a process over and over. And a task T here should be capitalized. This is an Earth Engine task. This is a task. I have a particular process, an export, an ingestion, whatever. I want to run that at a particular cadence. Here, I've said every week. We'll get to pick our cadence here. This is a really common request. Second, we're going to react to new data appearing in cloud storage. So this is a common flow. Folks have data that comes in from data providers. You have data that's collected in the field. When a new file is ingested into a cloud storage bucket, it will trigger an ingestion and automatically make that available in Earth Engine. So you don't have to do anything. You sit back and let data flow. And finally, yes, as promised, text messages. I want to get information about a particular area of interest. And I've stitched together, there's a data feed in Earth Engine called GOES that comes from a satellite that is geostationary and takes images very frequently, every 10-ish minutes. So I want to get some statistic, some measurement from that, and I want to log it, I want a graph of it, and I want a text message, I want an email, I want some kind of alert when it changes over a certain threshold or under a certain threshold, or give me some condition that I can get notified on. And in addition to these, so these are recipes, right? These are techniques. I really want to spend maybe the last 10 minutes talking with you all about the kinds of operationalization problems that you all have, and get a little more information for the next time we teach this. Okay? Case A, example A, task A. We have this export task that we want to run every week on fresh data. This is it. This is the architecture diagram. We are introducing, so everything here is going to, the sort of linchpin here are cloud functions. Cloud functions are these really cool things that enable you to, and if you were in Brady's talk yesterday, you heard about this a bit. They enable you to run small pieces of code in a serverless and in a context-free way. So you can put in a piece of code, and it can get executed, and it can run, and it doesn't have any other state. It can reach out. It can send HTTP requests. It's a real piece of code. It feels like you're running it on a machine. But you don't have to do any maintenance. You don't have to upkeep these. They're provisioned and run at a cadence that you specify. And the cadence here comes from the Cloud Scheduler. So the Cloud Scheduler is a tool that just lets you specify how often you call these cloud functions. And the mechanism through which that happens is this pub sub. And we'll talk a bit about pub sub in a moment. All right, so just digging into cloud functions, yes, they're serverless. Is that like a, cool, all right, yes, they're serverless. They can run Python, they can run JavaScript, they can run a lot of different languages. A lot of different frameworks and architectures are available in cloud functions. We are gonna use Python today just because that is the easiest in terms of shortest lines of code. I also have a JavaScript version that I've set up, but it's a little more boilerplate. So just to keep it simple and readable, we're gonna lean on the Python. But just know that you can, if you have Earth Engine code that's in JavaScript, this is a fine place to put it. Cloud functions are limited, so they can only run for a maximum of 5 minutes in terms of generation 1 or type 1. And then there's this new kind of cloud function that's a little bit in between, a little beefier. So these run longer, and they have more memory available to them, and they can do more intense processing. Nothing we're going to do is running for more than seconds, so this isn't a limitation for us. The thing I put down here about no persistence, so data doesn't persist between runs, but it kind of does. So digging into that a bit. When I run code in a cloud function, it disappears. The cloud function kind of goes away. It feels like a virtual machine that just starts up, runs, and goes away. There is a trick that you can do if you declare variables in the global scope. So if in Python you use the global keyword, there is a chance that that variable will be set the next time. And it's only a chance, it's not a guarantee. So the idea is if you have something that you want to persist, if it's something computationally expensive or takes a long time, it's possible to declare it as global and maybe have it available the next time that you run. I'm not going to be demonstrating this, but just know that if you're really into running a lot of Cloud Functions or really optimizing these, or you really want to shave CPU cycles off, that there are these tricks about persistence, and you can dig into that. That's kind of a theme here, is I am just showing some relatively higher level things, pretty simple flows, and I really want to encourage you to use these Lego blocks to build cool and interesting pieces. There's a question. Would you mind using the microphone?
Yeah. Does the lifetime apply to a running task or just the code itself?
Excellent question. Yes. So the lifetime only applies to the code that's running in the Cloud Function. So if we kick off an Earth Engine task, capital T task, an EE task, that task can run for the standard Earth Engine, 10 days that those tasks are able to kick around for. So if this is really, I think about it as like a controller. We set up, we kick something off, and then we are able to have that run in Earth Engine. So the big question is, what does it cost? Are these expensive? What's the catch? You can look at the right-hand box. Everyone gets 2 million invocations monthly, not charged against your cloud credits. I have never gotten anywhere near 2 million invocations. If you do, I'm really excited because that means you're using them super heavily. But no, this is mostly free if you're running even every few seconds. You got to work pretty hard. You have to call a lot of functions. Of course, there are cloud charges here. So when you exceed your 2 million, you start to pay for the cloud functions themselves. Before you get to the 2 million, there are the cloud costs of storage. If you have files that you're storing in Google Cloud Storage, those have you pay cents per gigabyte. You pay for the egress, the data that you're moving over the network, et cetera. And of course, if you're an Earth Engine commercial customer, you're paying for the Earth Engine operational use. You're paying for your EE compute units. Okay. One more sort of theory slide, and then we'll jump into the code. Earth Engine tasks do not have any pub/sub integration. So Earth Engine tasks, the tools that we're using to have the cloud functions sort of interact with the tasks. There are two strategies here. Because we don't have anything that will push when a task changes state, a push that says my task has succeeded or a push that says my task has failed that I can later react to, I either do two things. I set it and forget it. I just start the task and really hope. Or I have a secondary job, a secondary cloud function, some logging, some alerting to monitor the progress of these tasks. Okay? So we're just building pieces here, building blocks. Okay. If everyone could navigate here, we will try something exciting. I have a cloud project that I started from scratch. So we're going real clean. This is not even my machine. We're going to try this out. So TAs, get ready. Just gear up. You don't know what's coming. This will bring you to a GitHub repository. And this has a handful of examples and a super unhelpful README file that just says this. I will update it, I promise. We're going to start with example A. And so example A is a Python file. And just going, ooh, you can't read that. We define some behaviors here. And so this is a Python file that we're going to run in our cloud function. So I'm going to go through the setup, and ooh, I got to start hurrying. We're going to go through the setup here of how we handle events. So remember I said the cloud scheduler, there's going to be a lot of pieces moving around. Cloud scheduler is triggering our cloud function through something called pub/sub. Okay, so pub/sub has these events, and we'll react to the events here. We're doing it a bit inside out, but bear with me. So we react to these events. Nothing here is very fancy or sophisticated. We're just setting up the credentials. We're initializing Earth Engine with our project ID where we're running. And then we call this export composite function with our project ID. So what I'm doing here, the idea of this function is that it takes, at a very high level, and it's not super long, it just makes a composite and exports it. How do we get here? Yes, so I have a collection that I declared earlier, I built earlier. I made an image collection, it's an empty image collection, and it lives in my project. It's called weekly goes. So goes is taking a picture every 15 minutes. What I want to do, I've decided every week my manager asks me to create a weekly composite. So I have to go in and I build this composite for a particular area. Here I've selected California. And I look at all of the fire pixels for goes. So goes has this fire detection algorithm that they run on every image. And for every pixel, it says fire, not fire. There's some quality bands, et cetera. I can create a very deep aggregation and look for every pixel, was it on fire in this past week? And so that's in a nutshell what this whole script is doing. I'm not going to dig too deep into the Earth Engine bits because you all are experts now. But here we're just jumping back. We're looking at the time that this is called. We're going back to the last calendar week. So we're not going back a week from when this was called. We're saying, what week was this called in? Go back to the last relative week. This is this get range. And then we're taking a feature collection, we're filtering it, we're getting geometry, we're cutting it down, and we're creating a composite, and we're exporting that composite. And so this is flexible enough that when I call it once a week, it will go back a week, and it will construct the composite, and it will kick off my export, and we call task.start here. This should be completely unsurprising, almost boilerplate code for folks who have worked with Earth Engine Python before. I see some nods. That makes me feel good. Great. Okay. So now the wiring. We are going to go into our new cloud project. And folks in the back, thumbs up if this is legible. I got 1, 2, 3, 4. Perfect. Okay, that's enough. I created a new project. And so this is a new project. I would love for you all to follow along, create your own projects. The caveat, you know you can bail out early if you don't have a billing account. You need a billing account in order to turn on cloud functions and cloud storage, and those are required for the next couple of pieces here. So you can create a fresh project. Brady covered that yesterday. You will turn on the EE API. I'm going to go to Cloud Functions, and I'm trying to not cover all the same stuff, but let me know if you're completely stuck. I'll really let the TAs know. We go to this Cloud Functions page, and this is what we get. We get this gentle intro. It's a lightweight event-based asynchronous complete solution, blah, blah, blah. We want to create a function, and it will tell us that we have a handful of APIs that we need to enable, and so I'll do that now. This is really happening real time. We'll wait a second. As we're enabling these APIs, just know that, yes, some of them require a billing account, and that's the next step, is we're going to select which billing account we're using for charges as we incur them. Okay. So Cloud Functions, this drops us right into creating a first-generation Cloud function. We don't need all the computational heft of a second-generation function. I will call this example A. And is this still legible? I want people to be able to see it. Bigger, sure. Well, they took up a lot of screen real estate here with this second gen. Okay. So I give it a name. I pick a region for Earth Engine calls. If you're moving a lot of data to and from Earth Engine, you want to have your function run in the US. Here, we're starting a task, and the task is very small. All we're doing is building the description of the processing to run. So kind of doesn't matter where we run it. And we choose a trigger here. And so the trigger, remember the graphic of we have the scheduler, we have Cloud Function, then we have Earth Engine. The trigger is really how we expect that Cloud Function to be called. So here we expect to have PubSub. And of course, PubSub operates on topics. So PubSub is publication subscription. We have topics, are the sort of categories, the slots, and functions can, or tools can populate PubSub with publications, and they can also subscribe to publications. So you can receive messages through this. It's a message passing service, essentially. So we define the slot, and that slot is called a topic, and we can define a topic here. So I'm just going to call this topic example A topic. And the hardest part of my job is typing in front of people. We don't need to use a schema. A schema is a way of passing structured data through these slots. We really just need this to be, yes, fire off another task. Yes, run again. So it doesn't need to be structured. It's just sort of a presence absence thing. Okay, and we'll have Google manage the encryption keys and all. I don't know what message retention duration will do. I think that's a logging thing. Tell me when you find out. Okay, so we're creating this topic. We have this new topic that we've created. Great. We can fiddle with the runtime details. Here is where, if you want to get really sophisticated, you can choose a special service account to run this, special credentials to run this, and that's typically what I do, is I make a new service account. Let me see if I can just do that here. No, I'll have to register it. Yes, I will have to register it either way. We create a service account, or we can use the App Engine default. But whatever we choose here is the set of credentials which will run our cloud function. So you'll need to give that service account permission to use Earth Engine and to read data from storage, et cetera, et cetera. So just be aware that this is the step where you control that. Okay, and we need to hit save here, and we need to hit next here. And then this is where we get into the code. So this will become a familiar interface. We'll choose to run with Python 3.10. And you'll see that it changed from, as we hop around and select different languages, the default files that are populated here will change. And there are a couple interesting things here. This is where the different files live. This is the code for each of those files. And we have an entry point. This is the method in my code which will be called with the particular event that PubSub is pushing through. Okay, so we're jumping way back to the code here. I'm just going to select all of this and put this in my cloud function. Okay, and that's my main.py. And here you'll see there's this hello PubSub. And I get a warning, the specified entry point might not be present in your source code. It's right. We have a handle event function, and that's what we expect to have here. Okay, then we have, so that's main.py. The other file we have is requirements.txt. This is which packages we need to have. This is also listed in the GitHub repo. It probably would have been faster for me to type it, but we just need the Earth Engine API. And this version here is just a version from last week that I picked off. Okay. All right, and that's it. So we have this function, and we have this requirements file. And to make this live, we just hit deploy, and we wait. Caveats. I started a project fresh, so we'll need to register the service account in order to use Earth Engine. So we don't have the Earth Engine API enabled. We don't have a service account enabled. I'm not going to do that now just because there's a little juggling involved, but there's pretty clear instructions online for folks to do that. I expect that you all are using projects that already have the API enabled and already have service accounts registered. Does that resonate with people? Do folks understand the requirement there? Okay. In order to call Earth Engine, you need to have a registered service account. Okay, so this is, you can see this is still deploying. It actually takes, for me, what felt like a kind of surprising amount of time to deploy. We get our little spinner here. We will get all sorts of information about, or we have all sorts of ways of interacting with this. So we can get details about the execution. We can read the source that we're deploying. We can set variables. We can look at the trigger. Et cetera, et cetera. Here, logs, I think, are probably the second most useful feature here. Obviously, there are no logs. It's just creating the function. And then this testing operation lets me trigger this function, when it runs, this will be a nice blue box, blue button. I'll be able to test this and run it without having to go through the pub sub scheduler and doing all the wiring. So this lets me press a button and it runs, and this is a fine way of testing and understanding what the function actually does. Okay? So here's one I baked earlier. This is a function that's been running for a bit. No data is available. Not within the past hour. It runs once a week. Yeah, you can see it ran for like a handful of seconds here. So this is example A, and we get some nice logs, and you can see all the decent logs. The requirements here, so the bits that are magic that I've just skipped over. Creating the image collection where these images will be exported into is just something you do you can do that in the code editor, you can do that on the command line, just creating an empty image collection. Registering the service account, and that's it. Okay. So we get a bunch of logs here. You can see that we have tasks that get started if we manually click it. I'm going to go pretty quickly into the cloud scheduler. We'll look at the trigger here. So I want to, I'm working kind of inside out. I have the function which talks to Earth Engine. Now I have this pub sub topic. I can click this pub sub topic and we can actually make this real. So we can go into our pub sub topic and we can create, we can go into Cloud Scheduler. Cloud Scheduler. So Cloud Scheduler is super uncomplicated. Scheduler. Oh, maybe it is complicated. All right. So we can schedule a job. We have a handful of options here. We give it names. We define the region that it runs in. This is, again, just nothing new. We build a description. This runs example A. And this is the only tricky part that I want to highlight here. We declare when to run using this ancient format for cron. So if you have written Unix cron configurations, this will be familiar. It is, I filed a bunch of bugs trying to get them to make this nicer. But essentially what this lets you do is specify minute, hour, day, day of month for when your function runs. And there's a bit of arcane syntax. I'm not going to get into it too much. This 5 asterisks means every minute. It's essentially, each of these is a slot, and we have a special syntax for which of those. So if I change this to, for example, 15 in the minutes slot, it will run on the 15th minute of every hour all the time. If I change this to star divided by 4 in the day slot, so minute, hour, day, we'll get every 4th day until the end of the month. I apologize, this is just how this stuff has been done for a really long time. The recipes I'd like to give you are, this is running at the first minute of every hour. You can also run at the first hour of the day. If I can express it. And it will tell you exactly. So this runs at 1:01 a.m. every day in this particular time zone. All right. I'll just pick a time zone. Great. Configure the execution. We pick a target type. We have pub sub here. We choose our topic. And we have a message body. It doesn't matter. Again, we're just checking presence absence. So it really doesn't matter. And then we have a handful of retry options. This is where you can really play with the stability bits and really control how often you retry, how you back off, etc. So this will run. And this will, so this is all the configuration that I need to do to have that piece of code run every day at 1:01 a.m. Alaskan time, which is what I selected, which is probably not that informative. I'll just pause. Any questions? I know that was a little fast, but I just want to make sure we touch all the pieces. Question?
If you web search things like
Oh, we got microphones.
use the actual UI to make that string and cut and paste.
Yes, Andy's observation is that there are tools available online for making these cron configuration strings. Please use them. I don't have a particular favorite. My understanding is that the cloud team might build one, a nice friendly UI, but I'm not going to hold my breath. But yes, this, you will eventually either completely ignore these or just become familiar with the syntax here. Okay? So this is a thing which runs an Earth Engine task every day. And so if your job is to show up at your office, make a coffee, and run Earth Engine tasks, this is a fantastic tool because this means that you don't have to think, which is good. You can think about other more complicated things. All right. So that is, and I should say, so when we start these tasks, the tasks will get kicked off. And if the tasks start failing, the cloud function won't know anything about it. Remember, we have two options, set it and forget it, or we can have a secondary job, look over our tasks and monitor and make sure they run successfully. You can have a job look at the service account and see the tasks that are being run. Okay? All right. I will jump back here. No, further. Yes. So that's the first one. That's a recipe. Second one's even easier. There's no time dimension at all. We're just reacting to events that happen from Google Cloud Storage. So cloud storage is great because it automatically has wiring for when new files appear. You can choose to have that send pub/sub events through pub/sub, and functions can subscribe to those events and then handle the particular files that that have materialized in your bucket. Okay? So this is the high-level architecture. All we did was we swapped out the scheduler driving pub/sub to do a thing to cloud storage having pub/sub do a thing. And this is kind of cool because we don't even need to configure the topic. So I will jump in now. All right. So let's create a new function here. And you all have seen this by now. Example B, US Central. The trigger here, whoa, not that. You can see next to pub/sub, we have cloud storage. So we can click that, and we can configure all of the details on, oh, this is a super fresh project, so I don't even have a bucket. There are a couple different steps here. You can choose kind of what phase of life you want, how you want to interact with that file. If, for example, the file is deleted and that's the notification you want to get, if the file is being created, that's the notification that we want, or if somebody goes in and tweaks metadata, touches the file, changes permissions, et cetera, et cetera. So it's super flexible. Again, I'm giving you Lego pieces that you're going to be able to connect and make work for you. We will create a bucket here. Let's make a new bucket. That's not interesting. I am not going to do that in front of you all. It has similar settings, so we go in and we can choose which service account we want to run it with. This is all boilerplate. Again, I'll jump to one I baked earlier. Here is example B. I made a bucket called Feed Me CSVs. And, oh, I'm a goofball. I didn't show you the results of the previous one. You just took my word for it. Yeah, so we have these assets. Let me just show you. There's a little proof in the pudding here. in our collection, we have, you can see I did this last week, we have images that are coming in and we're creating composites of those fire data. So this is end to end. It works, I swear. Here's 2 times that it ran. And if we choose, we can go in and test it because it slides and creates an image based on the week. If we run it again, the task will fail saying, I'm not going to overwrite more data. Sorry, that was jumping back and forth here. I've had a long week. Okay, so we'll go into example B. And again, this is not super complicated. This one does pick some information out of the event metadata. So we have almost exactly the same configuration here. Our function is called GCS to EE, and we get an event and we get some context. Here we are just, and you can see I have some print statements here. These write to logs. That will become interesting in a moment. We print out some information. We say, hey, we're ingesting this file from a particular path. The event that we get has, so as I was debugging this, as I was building this, I just printed the event and ran the function, saw what I got. And I got pointers to cloud storage files. So we pick off this file. We pick off the bucket and the name from the event. And that's the pub sub event that's being passed in. And then we just do a super boilerplate Earth Engine asset ingestion. And shout out to Grace Coleman if she's watching this in the future. She wrote this. And we just start the ingestion task. And this is another set it and forget it. We fire off the task. We can look later, and we can have a job that runs every 10 minutes and looks and sees if there's any recently failed tasks. This is the bare minimum here. But we copy and paste this in. I'm not going to show it again, but we do the same thing. We have our Earth Engine requirements, and we have our GCS to EE function. And this one is cool because it's listening to this. Oh, where'd it go? Yes, feed me CSV's bucket. And if I put data, let me just delete this. Oh, I'm not on my machine. I don't have a CSV file. Let me download this and re-upload it. Oh, sorry, Brady, I'm going to show all your interesting files here. Nobody look at that. Close your eyes. Okay, deleting this. And so ooh, that was scary. You can remember we had the option of choosing kind of where in the life cycle we wanted to react. Obviously, our function doesn't get called when we delete this file, but boy, howdy, when we upload files. No. Oh, my God. Desktop features. Yes. Great. This will create a new feature collection, and in particular, I set this to, if you're paying very close attention and reading quickly, allow overwrite equals true. So this will always re-ingest the file to create a new feature collection called features. So in the spirit of things, this is one I made earlier. We're still waking up today. Here's our last modified date. You see this is October 1st. We will come back in a moment when this is done. We can check based on the logs. So let's look in the logs here. We expect this to have reacted to, yeah, great. We have logs from, what is today, the 6th. Here's our task ID, so we can look and fetch information about our task ID if we want to manually check it. We can have a dashboard populating these task IDs for recently run tasks if we want. We can run this with a service account, run this as myself so that I can see it in the Earth Engine UI. There's a lot of flexibility here. But here's our task, and I expect that this is finished already. I'm not going to go into the details of, yeah, look, last modified right now. Ooh, it's late in UTC. So here's our file. So we have, this is a way of plumbing data into Earth Engine, and I didn't touch any Earth Engine, nothing up my sleeves. We just dragged a file into cloud storage. So that's wiring. I see a question in the back. Would you mind? You got a microphone? Again, has got the mic. Yes.
So how would you go about debugging? Because you've used some of the event attributes, right?
Correct, yes.
Yeah, can you say like how do you do the debugging?
Yeah, so I'm gonna give you my honest answer as a Google software engineer, and then I'll give you what, like the correct answer, what you should do. I had a print statement in here, and I literally, like, the first time I ran this code, I just printed out what the event was, and I'm still doing that here. You can see this is the event, and you can see everything about all the information. It gives you the bucket information, the name of the kind of content that it expects, some hashes, some tags, et cetera. I just printed that out, and I was like, what do I have available? What's cloud storage giving me? A principled person would read the docs. You can also, I'm not covering it here because there's local setup that you have to do, but you can also configure cloud functions to run locally on your machine. And so you can do much faster debugging. You don't have to wait for them to deploy. You can run them on your machine. I'm not covering it here, again, just because you have to wire some pieces together. Okay, does that answer your question?
Yeah.
Okay, fantastic. So, 1 and 2, A and B. We ran a thing in an automated way, and we reacted to some new data that appeared in a cloud storage bucket. I'll just paint a little picture. For folks who have data in BigQuery or rows in Google Sheets, you can configure both of those tools to automatically dump data into cloud storage. And when those files appear, you can run something like this. So this is a nice way of connecting to other tools. This is not, hey, Earth Engine team, you don't need to build connectors to these things, because we do. But this is a nice way of connecting with, if you have a data collection application that dumps data into BigQuery, you can wire up exports into cloud storage, and the cloud storage files will automatically become ingested into Earth Engine. You can start to see that there's a bigger picture and a lot of interesting pieces to play with here. And that's really, like, spiritually what I would love you all to leave with here today is this set of examples and the set of the idea that there are a lot of different flexible pieces that you can stitch together. Okay. So there's our architecture. Last one, and we're going to go real quick. This is the one that texts. So the idea here, and this one's way more complicated, but not super complicated. We have our cloud scheduler. So I want to run this task every 5 minutes. I want to have it call a cloud function which checks and just says, are there new data? Are there any images within this 5-minute window that I need to analyze? If there are images, they get passed. We call Earth Engine to find out if there are images. If there are, then we use Earth Engine to compute a statistic over a region that we care about. And just for my own joy, this uses the feature collection that we just uploaded in example B. So you can now you can imagine like mixing and matching data between these cloud functions. So we're asking Earth Engine to analyze a particular region and log some information about it. And so I am measuring, this is a really goofy example. You all are smarter than I am. I'm just measuring redness. I'm literally taking the red band and a region, and I'm taking the sum. It's not interesting. It basically corresponds to the amount of sunlight, which is, I get a notification now every time the sun sets in California. How do I get that? Cloud logging is a really super powerful tool. We take the Earth Engine results, they go back to our cloud function, and this is where I didn't want to make it spaghetti here, but the cloud function uses Earth Engine to get some information, and we have the data go into cloud logging, and they're structured JSON data. So I have a field that is just redness and a number. I can then, using cloud logging, wire that into cloud monitoring which lets me have a dashboard and lets me see graphs of my numbers over time. And in particular, I can set up alerting through cloud monitoring. And I went in and I added my phone number as something to be alerted when the redness exceeds or falls below a particular threshold. And you, or in this case, me, that's the last step there. So I get text messages about this. This is great because it gives you dashboards of data that you care about. And if you care about more interesting statistics, like are there fire pixels being detected near my region, let me know within 10 minutes and give me a text message. How is precipitation affecting a particular area? Let me graph it over time and get an alert if it falls or exceeds, is under a threshold for more than a certain amount of time. Pollution events, I want to know if there's a significant amount of PM 2.5 pollution around particular areas of interest or within a corridor or just around my house because I'm a person who breathes air. These are all things that you can do and can wire up, and you are limited by your creativity, not mine. This is an example of a message here. So this is the kind of alert that you get. My project is named Personal Earth Engine, and the amount of redness fell below this particular threshold. So let's look at how this works. I'm going to try to do this quickly so we have some time to talk about your operationalization desires and interests, and a bit about where we're headed in the future here. So we'll jump to example C. Oh no, that is not how you drive GitHub. Okay. Here, again, everything you've seen before. We handle an event. There's no information in the event. This is being run by Cloud Scheduler, just like example A. If you're lazy, you can just turn example A into this. We have our goes image collection. I'm selecting the red band. I'm measuring the size of the collection within a particular window. So I said I run this every 5 minutes. There's a new goes image every 15 minutes, and I look in a 10-minute window. So my sliding window, I should expect to see the same image twice and do this analysis twice, maybe 3 times over a particular image. This is just making sure I don't get 2 images and I don't miss an image. But this isn't the most interesting part. Really, I just have a very primitive error handling. I say, hey, there's no new images, don't bother. Or there are too many images. If something strange happens, like they send more data than they're capable of. We have our feature collection. This is the feature collection that I made before. And then we just literally do a reduce regions call to sum up the redness in that particular area. We log it. So we fetch the results. We do a get info call if you're in JavaScript. You can also do this. Don't do it in the code editor. We call it get info. And then this particular, I just want to call your attention to the JSON dump string. This writes JSON, and in particular, so JSON is a structured way of sending around objects. And here we have a dictionary, and we're saying cloud here. See, I shuffled around the examples. Cloud or redness, whatever, with the number that we care to log. And it's important that we structure it as JSON because cloud monitoring understands these dictionaries. And so we can, in cloud monitoring, let's Personal Earth Engine. Actually, sorry, let's go to logging first. Cloud logging has these structured fields. There is a tool, if you go into cloud logging, and these are all things that you turn on, you enable cloud logging, you enable monitoring. We can go to logs-based metrics. And if I have a structured log, I can turn it into a metric. And that's the whole magic trick here, is that I can create a metric based on logs. And there are different kinds of metrics. I'm not going to get into all the details because honestly, I don't fully understand them. These are counters, and you have distributions. This is over time, how many of a thing happened, and over time, keep track of a histogram. So you're aggregating this histogram through time, and at an instant, maybe you have a value, but we think about it as a histogram. You fill out the metric names, you build a description, you build a filter. And so let me jump back to an actual filled out example. Here's redness. You can see I was playing around here. Let me edit this metric. So my redness is a distribution. I have a filter. I only expect to read logs for example C. And here's where the JSON really comes into play. My field name is JSON payload.cloud. And that cloud has to match what I wrote before, the field I'm logging. If you look, sorry, I did that too quick. If you look here and you preview logs, you'll see these green numbers stand out. These are actually the values that we see that match this metric. So for this metric, we're ripping through all these logs, and these green numbers are the things that get pulled out. And these numbers are powering our histogram-based metric. So at each of these instances, you can see it's logging 3 times because an image comes every 15 minutes, we run every 5. We get these metrics through time. And so we're turning these raw logs from our cloud function as it runs into metrics for cloud monitoring. Cloud monitoring, we can create a dashboard based on metrics. So we can explore metrics. We can look at my redness metric. I have a logs-based metric. It's not tied to any particular resources. We'll look at redness. And I will group by log. And I'll use a sum within a minute. Oh, no. I'll just go to another one I built before. We can, yes, here we go. Ooh, it's alerting now. It's firing now. This is our dashboard. Let me look into this. Sorry, 1 second. So we'll give this a second to actually do the interpolation. But this is what our redness looks like over time. You can see that this was maybe a cloudy day or something. The sun was less bright. I don't know. You will have a more interesting metric. You'll be watching for fire pixels, pollution, floods, deforestation, etc. These are the pieces. And so we have the details here. I will just really quickly jump back to try to show you how to visualize this cleanly. It's not letting me. But we can visualize these metrics here, and we can set alerts on top of them. I'm sorry, we have 5 minutes left. I really want to hear from you all. I'm going to go real quick. I'm just going to say that you can do that. I'm pointing to the pieces here. If you want alerts on a particular device, you can choose. I built a policy. So this is an alert that looks for a particular level and then notifies me on the channels that I chose. So I have my cell phone configured here as the channel. You can swap out these pieces too. So if you have a service, if you pay for your company has Google Workspace, or you have a custom domain and you're able to send email in an automated way, you can wire it in here. You can have a cloud function call it. If you have a service, you can pay to enable services. It's like $10 a month to send SMS. And you have to go through all this verification that I just didn't want to do. But you are able to send maybe your own SMS. Maybe you have groups of people in the field that need to be alerted, or you have employees in a location, or you have assets which maybe I run a separate cloud function. There's a lot of different pieces here, and I want you all to be excited about the different building blocks that are available. Okay, monitoring. So just real quick, make sure we covered everything. Logging, monitoring, you. Anybody have questions about how this should fit together? No. I'm going real quick. All right, so other architectures, you can choose to get alerted about other things. Many of these are measurable. I chose redness just because it changes pretty constantly. And so we get a nice graph out. We get an interesting value. The code is yours to go and play with and tweak. You can, I really wanted to have a fire demo. Thankfully, there are no fires burning in California right now, so I'm happy to not have that for my demos. But this would be a mechanism for you to get notified about that. Yeah, fires, floods, air quality, vegetation, anything you can model. So stuff you can sense, and then what you can build on top of that. You can have machine learning models. You can plug TensorFlow into this. Anything that Earth Engine can produce as a number or a prediction or an estimate can power this operational monitoring and alerting. All right. I am going to talk about our plans and ideas really quickly, and then, yes, I want to hear from you all. So what are some obvious next steps as we talk about powering more operational use cases with Earth Engine? For me, this is really about having more pub/sub integration. So in the same way that like integrating with cloud storage was a really easy thing, I want to make that really easy for Earth Engine and figure out really how we propagate task status changes. Oh, your task failed. Let me subscribe to that. Your task succeeded. Let me subscribe. Things like in the data catalog, subscribing when collections are updated or new images appear. There's some technical quirks around these, but this is a direction I'm really interested in pushing in, and if you're interested in it, make noise, help me out. Having just easier examples. These little snippets are on GitHub, but I would really like to have them in a repository which makes them easier to deploy. There are a couple different options for where does your code come from. You saw me just copying and pasting code in there, but you can choose to have, I think there are cloud source repositories, hold your code, and really that's what controls your cloud function configuration. And anything from you all. You should know this email address by now, but send ideas, complaints, grievances, questions, concerns here. With that, we have 3 minutes maybe for questions and answers, but first, thank you. I know that was fast. This is the first time we've taught operationalization. I'm gonna pick a shorter word the next time we do that. But yes, any questions? There are folks with microphones. I would love to get the microphones out just so we get the questions on the recordings. There's one.
Hi, thanks you for the presentation. Can you plug in the cloud functions to pre-process some data, put on the storage, and then run a TensorFlow model in the AI platform or Vertex, the thing?
Absolutely, yes. So you are able to wire these into, and the way I would do that is I would have Earth Engine call the model in TensorFlow, maybe with Cloud AI Platform. It's also possible, yeah, to call out. They can hit any internet address. You could have it go fetch data, store it, process it. It's really, they're super, super flexible. It's like having a little virtual machine that you control. There's another question up here.
Thank you. Thank you, Michael, for the wonderful talk. I had a question regarding how the cloud functions work with respect to, like, let's say, because I've used cloud functions in Firebase, which might be a little bit of a different thing. Here, you like copied and pasted your Python code into the UI editor on the website.
Correct.
Is there any way to like do that via like GitHub or any other platform to
Yes.
iteratively change the logic or change everything else?
Yes, and if we could switch back to my display for a second, I'll just show you where that happens. Sorry, I'm giving the AV folks trouble here. You can choose in the source tab. Shoot, maybe it needs to be in a new function. Let's go through. Whoa. You can choose to have the source be controlled by, okay, yes, let's just save this. Let's rip through this real quick. So the source code can come from zip files, from cloud storage, or from a cloud source repository. And that's what I was mentioning earlier. That's an integration that I want to have be easier, is so that you don't have to copy and paste and fiddle with that. I think cloud source repositories are probably the most robust way of doing it today. But not a lot of folks have those set up. So this is sort of the table stakes.
Yeah, love to get more of that.
Thanks. Anybody else? We're 30 seconds over, but all out.
Yeah, so if I understood well,
Yeah.
in your last slide, you said that you want to have like task status control. So that means that right now you cannot implement a workflow that is kind of split in multiple steps, or can you?
You can implement a workflow that has multiple steps, and you can wire cloud functions into each other, but you have to do that by either having pub/sub or having explicit calls, HTTP calls. I didn't touch on the fact that you can build HTTP endpoints out of these. That you refresh in a browser and it sends a particular piece of information there. Yes, you can wire things together. The task status that I was pointing to earlier is really about Earth Engine tasks. I want Earth Engine tasks to push information to pub/sub saying, I'm Earth Engine task XYZ, and I just succeeded, or I just failed, or I just had a state change, or I was just scheduled, etc. So those batch tasks, being able to really more easily get information about your batch tasks there and react to it. The future, hopefully, fingers crossed. Bother the engineering team.